Okay, so we're going to look at some different angle relationships in circles, and we're mainly going to talk about some different kinds of lines and segments that meet in circles. So namely chords and secant lines and tangent lines. So we're going to look at how all these meet and how the relationship is with a circle. So our first theorem says this: if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is half the measure of the intercepted arc. So let's kind of draw a picture of what this would look like. So I have this circle. So I have a tangent line, which we know meets at only one point at a 90-degree angle. So there's my point of tangency. And then I have some chord, whatever that chord would be. Let's say the chord is here. So if I call this A and this B and this over here C and then maybe a point over here D, then this angle, which in this case would be DAB, it's going to be half of this arc, which would be arc AB. So if a tangent and a chord meet at a point on the exterior, on the circle, basically on the circle, then the angle formed is half of the arc. So we sometimes refer to that as the tangent chord theorem for obvious reasons. So our second theorem says this: if two chords intersect in the interior of a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So if we draw a circle, it says two chords intersect on the interior of the circle. So there's one here, and here's one here. Now remember, chords don't have to be diameters. So what this says is if I take this arc plus this arc, and I add them together and divide it by 2, that will give me this angle measure here. So the angle measure is equal to the two arcs, we'll call it arc 1 plus arc 2 divided by 2. So I add the two arcs and I divide by 2, and that would give me my angle. And of course it's both angles, because this angle over here, because it's vertical, would be the same angle as well. Okay. One last theorem. So we did a chord, two chords, a tangent and a chord. So now we'll do a secant line. So if we have a tangent line, so we've already seen what a tangent is, and a secant line, and this is also true for two tangents or two secants. Okay? So it could be a tangent, a secant, two tangents, or two secants. If they intersect in the exterior of the circle, so they meet outside the circle, then the measure of the angle formed is half the difference of the measures of the arcs. So instead of adding the arcs together, we will subtract them. So let's draw a picture of what this looks like. So here's a circle. I'll just do two secant lines. Now they have to meet on the outside of the circle, which this one does. So we can find this angle measure by taking this arc and subtracting them and dividing by 2. So this angle measure is going to equal to the two arcs subtracted. We'll obviously subtract the bigger arc from the smaller arc, and we'll divide by 2. Okay, so what we'll do is we'll look at some examples of each of these theorems and how we can apply them, and with some actual numbers. Okay? So first let's look at some examples of the first theorem, which again, let's go back and rehash. It said if a tangent and a chord intersect at a point on the circle, then the measure of the angle formed is half of its intercepted arc. So if we look at example 1, we have this arc of 120. Now you'll notice here is a chord, AB, and we're saying CD is a tangent, so this is my tangent line. And they intersect on the circle. So this angle that's formed, so that's angle BAD, so the measure of angle BAD, it says the angle is half of the intercepted arc, and it intercepts this arc 120, so it's just 120 divided by 2, so the measure of the angle would just be simply 60. Let's look at example 2. Very similar kind of problem. We want to find measure of angle BAC. That is this angle right here. Because if I go BAC, that's this angle here. Now the arc I'm given is 200. So since the arc is 200 for this tangent and this chord, I know this angle DAB, so I know the measure of angle DAB would be half of that, so that's 100. So I know this angle here would be 100. Unfortunately, that's not the angle we're looking for, but since angle DAB and angle BAC, which is the one we want, are on the same line, I can just simply do 180 minus, because they're on the same side of a line. So 180 minus 100 will give me 80. So the measure of angle BAC, which is what I want, is equal to 80. So very typical of these circle problems where you have to find one thing to find something else that you're actually looking for. Okay, so let's look at one where we have a little bit of an algebraic equation to it. So we have chord BD, which is touching tangent CB at point B. So again, we have this whole tangent chord. So we know the angle is 1/2 the arc. This is kind of the theorem we've done the whole time. So the angle, which is 3x, is going to equal half the arc, so it's half times my arc measure, which is 4x plus 50. Now there's lots of ways to do this problem. I think the easiest way would be to distribute the 1/2, multiply half to both of these things. So 1/2 times 4x is going to give me 2x. 1/2 times 50 is going to give me 25. So I get 3x equals 2x plus 25. I'll subtract 2x, so I get 1x equals 25. So again, nothing complicated. It all comes back to the theorem that the angle is going to be half the arc when a tangent and a chord meet. Okay, let's look at some examples of the second theorem. Recall the second theorem said if you have two chords that meet inside the circle, the measure of the angle, so the angle is going to equal half of the sum of the two arcs. So we'll take the two arcs and we'll divide by 2. So in this case, you can see we have 120 as one of the arcs and 50 as the other arc that are intercepted by these two angles. So this angle x would simply be arc 120 plus arc 50, and then we will divide that by 2. So 120 plus 50 is 170 divided by 2, which is going to be 85. So in our problem here, we know this is angle 85. And because these are vertical angles, I'd also know this is angle 85. And I don't need it, but if I wanted it, I know that this angle is 95. And I know this angle is 95. Because 180 minus 85 is going to give me 95. So let's use this theorem one more time. So this one, we have a little different problem. If you notice, we have one of the arcs of 100, but we don't have the other arc. But we have the angle 70. So again, we know the angle is equal to the two arcs added together divided by 2. So if I plug that in, we get 70 degrees equals arc 1, which we'll say is 100, plus arc 2, which I don't know in this case, so we'll call it x over 2. So really we're trying to find 100 plus what divided by 2 equals 70. Again, lots of ways to do this problem. Algebraically, the first thing I would probably do is I would multiply both sides by 2, because that will cancel that 2. So 2 times 70 is 140, which will equal 100 plus x, and then I'll simply subtract 100 from both sides. So x is going to be 40. Now, so this found this arc, which is 40. And if we just do a simple check in our head, 100 plus 40 is 140, divided by 2 is 70. So that works out well. So let's look at some examples of the third theorem. The third theorem says if you have two secants, a tangent and a secant, or two tangents that meet on the exterior, then the angle that's formed by those two is going to be half the difference of the two arcs. And then again, they have to meet on the outside, and they have to be two secants, two tangents, or one of each. So if you look at this theorem, this is two secants because you can see they pass through the circle twice, and they meet on the outside. So this angle that's formed by these two secants, we'll call it x, is going to be equal to the difference of these two things divided by 2. So we'll take the bigger arc, which is 100, minus 30, divided by 2. So 100 minus 30 is 70, divided by 2 equals 35. So that angle measure is 35. Again, we're just subtracting the arcs and dividing by 2. If they meet on the outside and if it's two of these same lines. So let's look at this example. In this example, we don't have two secants. We have one secant. The secant line is this AC, and then this B up here is the tangent. But again, this theorem works for two tangents, a tangent and a secant, doesn't matter. So what I have to first find, though, is I have to find what this arc is here. Because remember, the two arcs that are intercepted are the ones we take the difference of. So this angle x is going to be 100 minus whatever this missing arc is divided by 2. Now, nothing complicated, because I know this arc is 220 and I know this is 300, and I know all the arcs in a circle must add to 360. So I'll just take 360 minus 220 minus 100 to get that missing arc. So that will give me 40 degrees. So this arc is 40. So now I can plug that in there, because these are the two arcs. Again, make sure that if you follow these two lines out, those are the two arcs it intercepts. It never really intercepts. The 220 is never inside. It's the 100 and the 40. So 100 minus 40 is 60, divided by 2, which is 30. Okay, this is another one where we have two secants, but you can notice we are missing the arc again. So again, we know the angle, which is 40, is going to equal the difference of the two arcs. So that would be 120 minus arc x, which we don't know, divided by 2. So this is going to be very similar to the example we did above with the chords, where we will try to solve this by multiplying first both sides by 2. Very traditional way to solve algebraic equations with a fraction. We multiply to get rid of it. So 80 equals 120 minus x. So to solve this, I would first subtract 120 from both sides. So 80 minus 120 is negative 40 equals negative x. So then I would simply divide by negative 1 to get x equal to 40. So this arc up here is 40. And that's just a coincidence that it's the same as this angle. That doesn't necessarily have to be true. The check is 120 minus 40, is that divided by 2 equal to 40? Well, it's 80 divided by 2, which is 40. So that is the correct arc. Okay, so this one has two tangents. So we have a tangent here and a tangent here. We have arc 250. But the nice thing is, since these two tangents intersect this arc 250, we really need to know this arc. But since those 2 points take up the whole circle, I can find that other arc by simply doing 360 minus 250, which is 110. So this arc is 110. And then again, our same theorem that says the angle formed between two tangents, two secants, or a secant and a tangent is going to be 250 minus 110 divided by 2. So our angle is going to be 140 divided by 2, which is going to be 70. So 3 really powerful theorems that we can use to evaluate circles. Please let us know if you have any questions on any of these theorems.